The construction begins by precisely outlining the UFO's dimensions directly on the workshop floor. Steel framework components are measured, cut to specification, and welded together, establishing the foundational scaffolding that will define the vessel's core structure. Earth material is distributed across the market perimeter. Workers shape this earthen layer using the steel framework as a guide, sculpting the cabin's contours. This forms a negative impression into which concrete mixture will be introduced. After the concrete achieves full strength, a separation compound is brushed onto its surface. The outcome is a durable negative template that becomes the starting point for fabricating the UFO vessel's main compartment. This chopped fiberglass matting is positioned over the concrete negative. Liquid resin is then saturated across the surface, subsequently curing and fusing the fiberglass layers into a unified composite shell. A steel structural cage is constructed to cradle the UFO-shaped hull during fabrication. This framework ensures positional stability and provides worker access throughout subsequent construction phases. The cabin's outer wall takes shape through successive applications of fiberglass matting and resin, applied directly over the supporting framework. Identical composite techniques produce supplementary structural reinforcements and support pieces that integrate into the evolving assembly. The concrete negative is methodically detached and lifted away from the newly formed cabin exterior. Excess fiberglass along the shell's perimeter is trimmed back and smoothed. The entire exterior undergoes thorough sanding to achieve uniform surface quality. Six-sided shapes are extracted from gypsum panels following the cabin's design blueprint, creating forms that will define the window apertures. Rectangular-shaped templates are affixed to the vessel's dome section, establishing cutouts that will admit natural illumination. The doorway template is positioned, supplying structural guidance while establishing the entryway's dimensions and profile. Hexagonal configurations are built up on interior surfaces using fiberglass and resin, producing decorative patterns. This approach yields a robust yet lightweight interior finish that enhances both visual appeal and structural strength. The vessel's bottom section employs identical fabrication techniques used for the upper cabin, though without the domed configuration. For viewers who've remained engaged with the build, consider providing a positive rating and following the channel. Your support directly contributes to content creation. The centerline stabilizer is constructed and attached beneath the hull. This component minimizes lateral drift from wind and current forces, promoting directional stability and navigation efficiency. Every joint and connection point receives additional fiberglass and resin reinforcement, establishing watertight integrity throughout the structure. Surplus material is subsequently trimmed away. The drive system is secured to the keel using specialized mounting brackets. Rubber isolation components within these mounts absorb operational vibrations, eliminating movement while maintaining secure attachment. The propulsion configuration begins with the jet drive mechanism, which ingests water through an inlet and expels it forcefully through a discharge nozzle for thrust generation. A rotating shaft links the jet unit to the power plant, transferring mechanical energy throughout the system. Following the addition of an intake grating cutout, the vessel's underside receives a dark protective coating that enhances durability and extends service life during aquatic operation. The fundamental construction phase reaches completion. The UFO watercraft's structural skeleton now stands assembled, encompassing upper and lower sections, centerline keel, and integrated propulsion. Entry and window templates are extracted, and all aperture edges undergo trimming and smoothing to eliminate irregularities remaining from the molding operation. This preparation enables the installation of access doors, viewing panels, and finishing elements that will complete the cabin's form and operational capability. The exhaust assembly is built, incorporating a water-cooled silencing chamber. This component blends cooling water with heated exhaust emissions, simultaneously reducing temperature and sound output prior to discharge. Flexible hosing is fitted over connection points with secure placement. Hoses and retention clamps firmly link the silencing chamber to the exhaust manifold and discharge piping. A control tube is installed for the steering connection, joining the handlebar controls to the directional nozzle. Handlebar rotation pivots the nozzle laterally, redirecting the pressurized water flow to guide the watercraft. The steering linkage threads through designated hull passages and aligns with interior structure, then connects securely to the control handle. This configuration translates handlebar inputs directly to the rear-mounted steering nozzle. After aperture edges are refined and fitted correctly, the pilot's seat is firmly mounted in its designated cabin location. The power plant enclosure is fabricated using gypsum panels overlaid with fiberglass and resin, producing a lightweight, corrosion-resistant assembly well suited for saltwater environments. The finishing process commences with the interior spaces. Multiple uniform paint layers ensure complete coverage. Subsequently, the exterior receives a final application of marine specification coating, delivering lasting protection against severe marine exposure. The access door is manufactured using materials identical to the hull construction. After shaping, a protective layer is administered, followed by plaster application to eliminate surface defects. For enhanced strength, the door receives an extra fiberglass and resin lamination. The door is separated into two distinct segments to facilitate easier entry and enhanced functionality. Post-cutting, excess material is removed and all edges are smoothed for proper fitment and safe handling. An operating mechanism is fabricated using steel bars, heavy-duty fasteners, and power tools. Steel components are cut, formed, and assembled into hinges and support arms that permit smooth door section movement. The system comprises two primary elements: the stationary base, which remains fixed, and the articulating components which enable door operation. Using threaded fasteners, the articulating bars functioning as hinges are rigidly attached to the mechanism's stationary portion. The doors receive spray application of marine-grade coating matching the vessel's exterior. Multiple uniform layers ensure complete coverage and moisture resistance. Textile material is precisely applied to the door's interior face, creating a smooth, uniform, and aesthetically pleasing finish. This treatment enhances the door's appearance while serving practical purposes. The fabric layer masks minor flaws, including surface variations or texture inconsistencies resulting from the manufacturing process. The opening mechanism's position on the door is marked and precisely cut. The mechanism is mounted using specialized adhesive for secure bonding and reinforced with robust fasteners for additional stability. This meticulous installation ensures the door remains easily operable while enduring the rigors of a marine environment. The builder assembles a push-pull control rod mechanism, a device typically employed to transmit motion and force from an actuator to a hinged component. This system enables precise and dependable door movement. Initially, a servo motor is assembled to govern the opening mechanism, receiving electronic signals to rotate and actuate a linkage controlling door position. Subsequently, a threaded rod connects to the actuator as a push-pull linkage. A helical spring is incorporated to absorb mechanical shock, and electrical wiring connects the actuator to the control system. Textile material is applied throughout the watercraft's interior surfaces, matching the treatment applied to the door components. LED illumination fixtures are installed within the cabin apertures. Electrical wiring is discreetly routed behind interior panels, connecting the LEDs to electrical power and control systems. This installation provides both practical and aesthetic illumination, improving visibility while enhancing the futuristic appearance of the UFO-inspired watercraft. The instrument dashboard is mounted and integrated with the watercraft's electrical and control networks to facilitate overall vessel operation. The fuel reservoir is positioned beneath the operator's seat, efficiently utilizing available space while maintaining proper weight distribution throughout the vessel. Fuel supply lines connect the reservoir to the power plant with careful routing to prevent leakage. This configuration ensures safe and dependable fuel delivery, enhancing both functionality and safety. Following the power plant's configuration, all connections are securely established, ensuring the engine is fully integrated with electrical and fluid systems and prepared for dependable operation. The Accelerator pedal is constructed using several essential components: the pedal pad, pedal arm, pivot point, return spring, and linkage, all interconnected to function as a unified assembly. The linkage connects the pedal to the propulsion system. Pedal depression regulates fuel delivery, thereby modulating the watercraft's velocity. Transparent acrylic panels are cut to precisely match the window opening dimensions. This technique is frequently utilized in do-it-yourself or semi-professional applications to substitute glass or fabricate custom windows for marine vessels, residential structures, outbuildings, or vehicles. Cutouts are formed along each acrylic panel's perimeter, then primed. Subsequently, automotive window tinting film is applied. These films utilize advanced ceramic technology to absorb and deflect thermal energy and ultraviolet radiation without employing metallized materials that could disrupt electronic signals. They additionally enhance privacy and protect interior spaces from solar degradation and color fading. Photovoltaic cells are installed on the watercraft's exterior surface, specifically on the upper surface, with maximum sunlight exposure. Conductive strips known as bus bars are attached to each solar cell, connecting them sequentially to create a continuous electrical pathway that transmits electricity between cells. The solar cells transform sunlight into electrical energy, supplying a renewable power source capable of charging battery banks or powering onboard systems. All window components are positioned and secured into their respective openings using premium silicone adhesive, which establishes a flexible, watertight seal that prevents infiltration and withstands marine environmental stresses. The UFO-shaped watercraft stands fully assembled and prepared for operational testing and water launch. It awaits bringing the creator's concept to reality, ready to glide effortlessly across the river as originally envisioned. Following innumerable hours of commitment, craftsmanship, and creative vision, the UFO-inspired watercraft achieves completion. What originated as an imaginative concept has materialized into an extraordinary reality. Every aspect, from the precisely constructed fiberglass cabin to the robust propulsion system, demonstrates the passion and resolve underlying its creation. This watercraft transcends mere transportation. It represents the creator's dedication and dream pursuit, transforming raw materials into a functional artistic achievement. Each component conveys a narrative of conquering obstacles, demonstrating that through dedication, even the most ambitious concepts can materialize. If this project captured your interest, remember to subscribe.